Good day, everyone. My name is Judelyn Patero from Northeastern Mindanao State University, Cantilan Campus, Surigao del Sur, Philippines. My talk is entitled Design and Fabrication of an Improvised Young's Modulus Apparatus. So Young's modulus is a fundamental concept in physics, and teaching this concept needs apparatus that allows a student to perform actual experiments rather than reading, because this could enhance students' curiosity and eventually improves their class performance. However, acquiring laboratory apparatus for this purpose remains a challenge in the basic education and even in the higher education level, especially to countries like Philippines, because these are very expensive like the ones distributed by Fisher and Pasco Scientific. In the Philippines, it takes months and even years to acquire such apparatus due to the state procurement procedure that we have, since such instruments can be purchased only from outside of the country. So to help aid the challenge of unavailable and expensive laboratory apparatus, particularly in the demonstration of elasticity of matter, fabrication of this apparatus was conducted. This paper presents the design and fabrication of an inexpensive improvised apparatus used to determine Young's modulus of selected metallic wires. For the methodology, so these are the materials and devices used in the fabrication. The dimension of this apparatus is 132 cm by 10 cm, and the required power supply is 3.6 volts. These are also the salient features of the apparatus. So figure 1 is the apparatus assembly. Figure 1B is called the sensor contact, and this serves as an extension to the pulling arm of the spring balance. Sensor assembly is also consists of contact sensor indicator that lights on if the sensor contact touches on the thimble of the micrometer, and a micrometer caliper where you can read directly the elongation. The tensioner assembly showed in figure 1C is also consists of improvised spring balance that provides load to the Young's modulus apparatus and a spring holder that can be adjusted according to the desired load. And figure 1D is the test wire anchor. So these are the method in the construction and fabrication procedure. So after the fabrication, we tested the apparatus manually using 3 different metallic wires. The testing is done in a normal classroom condition with no control over humidity. The apparatus is not temperature sensitive, and the data accuracy for all the measurements is plus minus 0.05 mm. So we tested using 3 metallic wires, one for copper that is 0.42 mm, GI wire of 0.555 mm, and the stainless wire that is 0.42 mm. And for copper and GI wire, it really shows linear relationship between the load and the elongation. However, for the stainless wire in figure 2B, the elastic behavior is only from 400 grams to 800 grams, and after that the elastic limit has been reached, and we have that in the upper part, the inelastic deformation. So in determining the experimental value of the Young's modulus for these metallic wires, we use the principle of least squares and then compare it with the standard using the formula here. And we can also show or calculate the experimental value of the Young's modulus as given by the equation also below, where the slope is, or where the Young's modulus can be expressed as 1 over the slope, that is 12.5 d squared times y, and then multiplied by 12.5 over d squared. And using the above equation, For the calculation of the modulus, we summarize the values of this in the table 1. So we have this table, and then the percentage difference is also calculated using the equation below. So in conclusion, data proves that elongation is directly proportional to the load. Analytically proves that the proportionality of the stress and strain is the Young's modulus. The fabricated simple and inexpensive Young's modulus apparatus is simple and consists of relatively inexpensive off-the-shelf material. It actually minimizes the computation that in many instances also proves to be deterrent in the understanding of the concept. It is very versatile and easy to build. It is excellent for high school and even in the tertiary education or level, and best for classroom demonstration. So this can also be used in introductory physics laboratory experiment. Thank you.